DJ here from smokescreendesign.com. There's a question someone asked, how can it be winter in one hemisphere while it is summer in another hemisphere on a flat earth? Because, well, it just doesn't work on a flat earth. It can only work on a sphere globe earth. So I wanted to just do a video on that and showing the movement of the sun and the moon. So I just want to kind of briefly go through this video that Rob Skiba did on how the four seasons work on the flat earth model, and also shows the phases of the moon. I think this is a really great video that he put together, and I can't imagine the amount of time that he had to put into it, but it's really fascinating. It doesn't seem to line up with at least the moon, how it moves on timeanddate.com. I was checking that out, which don't know if time and date is absolutely accurate, but it does have some accuracy to it, as I've done some measurements using their information, and so far it's been accurate every time I've used it. So in the flat earth model, if you don't know how it works, the sun and the moon spin around above the earth, and the earth is stationary, and we can see that the moon is going through its cycles, and some people say that the moon is self-illuminating, others say that the moon reflects the sunlight, others say that the moon is being charged by the sun, and then I don't know if it's like a glow in the dark kind of thing where it gives off. I'm not sure. So far, everything that I've seen proves that leads to the theory that it is the moon that reflects the sunlight. I haven't seen really any proof of anything other than that. But as you see that the sun and the moon, that they spin around and they stay between the Tropic of Cancer, which is up north, and the Tropic of Capricorn, which is down south. And I'll show you that here in a second. And then here's the equator, and it just circles around. And check out this video and you'll see that on the left we have the month, the day, and the time. So this is a great thing that he put together, and pretty amazing. So let's go to stop that. So what I did, I took time and date, and I took screenshots just to see where they place the moon and the sun during different times of the year, and I marked them all off, which it looks a little confusing right now because there's a lot of dates on here. And I didn't go through every day. I just did the first of the month, and I started, which is right down in this area, started with December 2014, and I went all the way to December 2015. And this top line is approximately where the Tropic of Cancer is. This line here is just above the equator, and this line down here is right around the area of the Tropic of Capricorn. And the sun and the moon, they just move between these two locations, these two lines. So starting out, we've got this first one is based on noon in the Kansas City area, which would be here in this middle. So you can see how far south the sun is in December 2014. So we see down here December 1st, 2014. And it's when I look outside, I should see the sun in the south sky, and this would be overhead at noon. And it's not likely that I would see the moon. Now, with the sun down here in the Tropic of Capricorn, the sun is close to the Southern Hemisphere, as many of us like to call this Southern Hemisphere flat. So it's going to be summer because the sun is close down here. For flat Earth, the sun is not 93 million miles away. It's close. And you can see the influence of the sunlight. This is as far as the sunlight travels. It doesn't go any further than this. So it's summer, and the sun is further away from the northern, so it's winter. So let's go to, and notice the moon over here. It's right around the equator. And of course, the sun and the moon on this map, they're much larger than what they would actually look like. So let's go to January. So January, the moon goes from the being around the equator and it jumps way up here. So here we're January 2015, and the sun stays in the same place pretty much. So not much of a move on the sun. It's still just about on that same line. It just shifted north a little bit, but we see the moon had a huge jump in the location of where it's moving. So let's go to February. So February, the sun is on this next line, and the moon is moving further north. Let's go to March. And let's see, the moon moved down, so it was up further north, now moved down south. And we see that the sun is moving towards the north, and we're now starting to head into spring, and we see that the sun is moving closer to the northern. So we are March, this is March 1st. We're still in winter, but now it should be starting to warm up a little bit. Now we're in April, so we're in spring, and the sun and the moon are on the same exact line. Now, if timeanddate.com is exactly right, which there's some discrepancy as the complete accuracy, but the sun and the moon are now traveling on exactly the same line. April. So you see how much closer the sun is to the northern, just above the equator. So let's go to May. So it's definitely getting warmer, and the sun is moving closer to us, and we see that the moon is now heading south, just like Rob Skiba's video we just saw, how the sun and the moon, they kind of exchange the path that they're on. The moon is heading further south, the sun is moving further north. And it's in May, it's definitely getting warmer. June, the moon is going further south, and the sun is further north. It's barely going to move any further north, barely. It does a little bit when it gets into July. So this is June 1st, not quite the peak of summer yet. Let me see, the moon still kind of in the same place. Now we're at July 1st, and you can see how high or how much closer the sun is to the northern hemisphere, or hemisphere for you spheroids. So it's very close to the northern, and it's much warmer, and you can still see the influence of the sunlight, how far that it travels. It doesn't go all the way to south, doesn't cover this area. No, people think that it doesn't cover this area because the earth is a sphere, but also on the flat earth it just doesn't travel that far. So now when we move to August, now August 1st, it's coming back down. It's heading south. The moon is heading up north. Moon's going further north. The sun is coming further south. October, coming further south, pretty close to the equator. So October, we're in fall. It's definitely cooling off some. Further away, moon is going further north. Now we are in November. It's definitely way further south where it's cooling off. The moon is going further north. And back to December. So as you can see that it's just a matter of the sun traveling between the two lines. Tropic of Cancer, Tropic of Capricorn. The moon travels between the two lines. So that's how summer and winter works. That's why we have different seasons between the separation above and below the equator. Very simple, not very complicated. Now, what's complicated is once you get into how the sphere works and the movement around the sun, and it just starts getting complicated, and people are bringing up questions that are, um, that need some answers. So just you can search those out, just like in 6 months when the sun or when the earth goes from one side of the sun to the other side, why is it that noontime on one side is in full sun, but noontime on the opposite side would be full darkness? So there are things like that. But I just wanted to show how you can have winter and how you can have summer on a flat earth. Real easy.